Hello, my name is Rob Garner. I'm an instructor at C&M, and today I'm going to demonstrate how to use operators in C++. First, we're going to open up Visual Studio. Next, we're going to go to File, New, Project. It'll be a Visual C++ empty project, and we'll call it Operators Demo. I'm going to save it on the desktop and click OK. When the project opens up, we'll see our project in the Solution Explorer. I'm going to go to the project itself. That's the second thing down here. It says Operators Demo, not the solution, but the project. Click on Properties, under the linker, and System. Under Subsystem, I'm going to select Console. That'll ensure that our console stays open when we run our program. Next, I'm going to add a new item. I'm going to pick a C++ file and call it Operators Demo. Which will open up Operators Demo in the solution file and allow me to start typing my code. We'll start off by placing our standard items that we have for a C++ program. We're going to include the IOStream library so that we can do input and output to the console. And we'll use the standard namespace. And define our main method, which is the first method that the operating system calls. We'll return 0 so that the operating system knows that everything executed OK. We'll add some comments. A slash star starts our block of comments. We'll close our comment block with this final star and slash. All these other stars don't actually do anything. They're just like any other characters, but it's one way of making kind of a standardized looking block. And we'll put a single line comment which starts with 2 slashes. And for single line comments, everything is ignored from the double slash to the end of the line. And that's why we can use those to do single line comments. For our first part of this demonstration, what we'll do is we'll look at multiple assignments. I'm going to declare 3 variables, and I'm going to say A equals B equals C equals 0. And to display it, I'll use the standard out method, console out, cout, and display the results of all of these assignments. And so what will happen here is this first line here will declare 3 variables. The space will be allocated for A, B, and C, but they won't have their initial values. And fact, and then what will happen is next I'm going to set A equal to B equal to C, and C equal to 0. And for this reason, it's better to read this equal signs as assign the value of. And so A is assigned the value of B, which is assigned the value of C, which is assigned the value of 0. And so you can see that actually, if you read it that way, the compiler is going to first assign the value 0 to C, then C being 0 will be assigned to B, which will make B 0, and then B being 0 will then be assigned to A, which will make A 0. So all of these should display 0. I'm going to hit Control F5. It'll ask me if I want to build because I haven't built this project yet. I'll say yes. And we can see down the bottom left that build started. Build then succeeded, and then our program is run. And what you can see is that in fact A, B, and C are assigned the value of 0. To show you what happens if you don't do this, I'm going to comment out A equal to B equals C equals 0, and we'll run that. And what that'll do is it'll make sure that this line does not get executed. And we can see that an uninitialized local variable A, B, and C was used. The compiler actually won't let us initialize. So obviously A equals B equals C equals 0 does in fact work. Another way we can demonstrate this is I'll set the value equal to 5 and run it. And we can see now that A, B, and C were assigned the value of 5. So you can do multiple assignments all in one line like this. We generally don't recommend that, as it's not as clear as putting them all on separate lines. But it's important to understand that C++ can process multiple assignment operations like this. And you'll find that sometimes is relevant when you look at some more advanced commands. For the next exercise, I'm going to change this to fractional calculations. We're going to do fractional calculations. And I'm going to declare a double called x, and we're going to do a fairly complex formula where we'll have some addition, some multiplication, and we have some multiplication, some subtraction, some division, and we are going to also have a combination of integers and doubles. So 5.0 is a double, 4 is an integer, and we'll see how this can affect calculations. So I'll build it and run it with Control F5. We have to actually display our result. And what you can see is x becomes 1. So how did it get 1 out of this large formula? Well, what it did is there's an order of operations that C++ performs, and in this case multiplication and division as a whole are done first, and then addition and subtraction are done next, and within that context operations are done from left to right. So if I look at this formula, First we'll do the multiplication and division operations, which are 5 times 4 and then 6 times 7, and then that result divided by 2. So first 5 times 4 is 20, and then 6 times 7 is 42, and then 42 divided by 2 is 21. So then I have 20 and 20, so then I have 2 plus 20 minus 21. Then, so that would be done first and result in 20, and then this is done next, which is 42, and 42 divided by 2 is 21. Then the next operation is additions and subtractions, and this is done from left to right. So 20 plus, or 2 plus 20 becomes 22. 22 minus 21 becomes 1. And so that's how those operations are completed. So the next operation I will do is we'll do another one. This time I will declare a double called y, and we'll do this same operation, but we'll add some parentheses. And if I put some parentheses around the first operation and the last operation here, we'll actually change the order of execution. So in this case, what will happen is the operations should go in this order. First, the calculations are done in the parentheses. So this left one and this right one. And this left one will yield 7, and this right one will do the operations within this, starting with the multiplication and then the division, and then all of those will be completed. So let's look at the result first. And we can see that y ends up becoming 7. So how did it get 7? Well, first we do 5.0 plus 2 will yield 7.0, so that will be a double because we're combining. Whenever we do a calculation involving a double and an integer, it widens out the operation and converts the result to a double. Then we do this operation first within this parentheses. 6 times 7 is 42, and it's a double, and then 6 times 7 is 42, which yields 42.0, which is a double, and then we divide 42.0, still saying the parentheses because we haven't fully resolved it yet, and then that will give us 21.0. We now have a new calculation without parentheses, with all the parentheses fully resolved, and 7 times 4 is 28. And 28 minus 21 will now yield 7. And that's in fact what we get. So we can see that the order of operations can be modified by the parentheses. We'll do another one. Z is equal to the same formula. But this time we're going to put the parentheses in the middle. And if we look at this operation, what we get is first we do the parentheses and we do the multiplications first, and so 5 times 4 will yield 20.0. 20.0 minus 6 should yield 14.0. I can get rid of the parentheses because it's fully resolved. And now we'll do from left to right, starting with the multiplications divisions first. So 7 times 14. So that should be 38, I believe. And 38 divided by 2 should be 19. And then 2 plus 19 should be 21. I think I got that wrong. Let me try that again. So first we go inside the parentheses. 4 times 5 should be equal to 20. Minus 6 should be equal to 14. Then we do the multiplication first. So we get 28 plus 70 is 98. Divide that by 2, and that will give me 49.0. To add 2 plus 49.0 should be 51.0. And in fact, that will resolve to 51. Let's do another one. Sam will define Q. Let's see if we can figure this calculation out. And we're going to put, this time we're going to put the parentheses around this middle section here. So if I were to calculate this out, I obviously do the operation in the parentheses first. I don't do this 4 minus 6 first, I do this 4 times 7 first. So 6 times 7 is 42. I subtract 4 minus 42, which should yield minus 38. (38) divided by 2 should yield, this is actually minus 38 divided by 2 should yield minus 19. And then now we do the multiplications first, so 5 times 19 should yield 95, minus 95. If I add those two together, I should get minus 93. So we expect this to be a minus 93. And in fact we do. So whenever you have to do these calculations trying to predict how this is being done, the items inside the parentheses are done first, then the multiplication and division, and you do all the multiplication division first, going from left to right, and then you do the addition and subtraction going from left to right. For the next exercise, let's delete what we've done so far. You can also comment out things. If you want to comment out your code to keep it, hit Control, K, and then C. And it will comment out everything all at once. But what we'll do is we're going to delete everything just to make it easier for you to see on this demo. So I'm going to call this demonstration wrong and right way. And the first thing we're going to do is declare some doubles. And you can see we can actually use the same type and then declare multiple items, and I can put them on separate lines. This is considered an acceptable way of declaring multiple things all at once, but keeping them kind of clear as well. And we're going to create a formula. And this notation would work fine using most standard algebraic equation, but you're going to see that it doesn't work very well in C++. So ordinarily we would think that this would work. And we see we have a red squiggle here. It says, expression preceding parenthesis of a parent call must have pointer to function type. And this is another case where Visual Studio is confused by what you've written. This is a completely correct notation for algebra, but for the computer this doesn't work. In order for this to work, we have to put a multiply. And that's how we can declare this this formula using the notation that's standard for C++. So don't get confused between standard algebraic notation, which is used in your algebra class, and how we declare things in code. In code, we have to use pluses, and we have to explicitly say where the multiplications are, and we have to use the symbols that C++ understands. And in this case, this will work. C minus D. So if we do these operations, everything in the parentheses is done first. So we get 3 times C minus D is minus 1. So we get the minus 3. Another common mistake is trying to divide A plus B divided by C minus D. And this actually works, except for we would think that we would get 3 divided by minus 4, or 3 minus, so A plus B would be 3, and C minus D would be 3 minus 4, which would be minus 1. And you think that you're going to get minus 3. But you get minus 2.333 repeating. And the reason is because it does the division of 2 divided by 3 first, and then it does 1 plus 2 divided by 3, and which is the 0.333, and then minus 4. So to really represent what we meant, you have to make sure that you explicitly define which elements get done first, and by putting the parentheses in, we may get more of the result that we want, which is to add A plus B and then divide by C minus D, which gives us the minus 3 we might have expected. So make sure you use your parentheses correctly to define what you want. Another formula we might look at is perhaps a common surface area formula, and sometimes you might think that you could write it this way. So in order to do pi r squared, you might say pi times radius squared, so multiply radius twice. But again, this won't compile because although it in standard algebraic notation, if you put something in parentheses next to each other, they that represents multiplication. In C sharp, that does not equal multiplication. So someone might try to fix this by doing it this way. And in some languages, star star represents raised to the power of, and you can see that star star doesn't do that in here. So this doesn't work either. We get the error operand of star must be a pointer, so it's confused. Another common symbol that you'll see in some programming language is this up caret, which doesn't work either, which drives another kind of weird error. We can do it this way, however. Pi, and here you see no errors. And this actually works. So we can take pi, multiply it 2 times to get a square, and we get the actual surface area calculation this way. Now this obviously is not particularly elegant, and what happens if you want to raise it to a different power than 2? So it'd be nice if there was a formula that was along these lines, where we had a function which we pass it the radius, and then we pass it the power we want it to be raised to. If I compile this right now, however, oh, it does work. So this is a math function. And what it does is it raises the radius to that power of 2. Normally we need to include that library. And power is a function that's in the C math library, and it will allow us, and the way you read this formula is multiply pi times the result of this function. This function called POW, or power, takes 2 arguments. The first argument is the item that you want to raise, and then the power that you want to raise it to. So this takes the square of radius here, 5.5, and multiplies it by pi in order to get the surface area. Another formula we could look at is a square root. And so we'll declare 4 doubles, m to receive the value, which will be and then we're going to in x, y, and w. And if you're using standard algebraic notation, you might write it like this, and we see that we get an error. That's because the dot, while that's considered multiplication in standard algebra, doesn't work that way in C++. Also, putting 3 in y actually doesn't work either. It doesn't multiply 3 times y. We have to do this using asterisk. So this is x times 3 times y in order to get these to multiply out. And if we run this, need to make one more change. And what we see here is that we can use a square root function offered from the math library. So you can look up the a lot of math functions in this CMath library. And you can see a number of functions which are available to you. And we use the square root function. We find it here. And it kind of describes what the function does and what the formula or format of that function is, even giving you a little bit of an example. We also used the power function, and here you see we pass it 2 doubles, and it tells us a double representing the number to be raised to a power, and a double precision floating point number that specifies the power. So that tells us the format of that function, and then it tells us what it does. So you can use MSDN documentation to find whatever formula you want. Another formula that we can look at is, let's look at how angles are treated. Angles, generally speaking, are done in radians. So in this case, 0.5 would be half a radian, which is about 90 degrees. And we might say, well, we'd like to define this function f of angle, and that, again, this would be a standard way of doing things if standard algebra worked, but C++ is not standard algebra, and you might try to then display angle this way. Well, it doesn't quite work, because what we get is expression preceding parentheses of parent call must have pointer to function type, and this kind of confuses the computer, because it's expecting this to be some kind of function, and that doesn't actually work. So in this case, instead of define it this way, we'll define it as, we'll give it just a full variable name. It's a regular variable name, and then we can kind of make this work. But again, we're using standard algebraic notation, and that doesn't work quite here. We need to put an asterisk for a sign. and I actually need this to be angle. So in C++, you'd probably represent that formula this way. 2 divided by 3 times the sine of our angle and then we would get our formula to actually work. So again, make sure you write your formulas in a notation that makes sense from a C++ perspective. You sometimes have to translate the standard algebraic notation into C++ notation. The next thing we're going to try is increment and decrement operations. So let's take a simple case. We'll set an integer equal to 5, and we'll say I equals I plus 1, and we'll send that out to the output. So what does this do? First I is set equal to 5. Then it's equal to itself plus 1. You can actually add things or multiply things to themselves in C++. And the result is I becomes 6. So I started off as 5, and then we added 1 to I, and then we reassigned it back into I, and now it becomes 6. So this is a common operation that's done. We'll see it more in loops, but it's often used as a way to keep track of a counter. And since it happens so often, C++ has added a simplified operator for it, where we just say plus plus I. And what this does is this plus plus means increment. And in fact, C++ comes from this operator, the name for it. So if I run that, again, we get the expected result. I starts off as 5, we increment it 1, and we get a new I. We can also have a version of that where the plus plus comes after it. And again, it will do the same thing. It'll simply add 1 to I. So you can put it in front of or behind it. But what's the difference between putting the plus plus in front or behind it? Well, one of the powerful things about that I plus plus operator is that you can actually do it in line. So we could do it this way. And I'm going to repeat this operation. It'll become obvious in a little bit. But we're going to see what I is initially, and then we'll see what it is after. So if I hit Control F5, we see that, as expected, I was incremented 1, and we didn't have to do the operation. We could do it in line with the previous statement, so that's kind of powerful. And I retains that value. Now watch what happens if I put the plus plus after the I. We see that we have this plus plus operation, but at this point it's still 5, and that's because if the plus plus is in front of the I, that means do the operation before you do anything else. If it's after the I, then it'll do it after anything else. It'll be resolved as I first, and then 1 will be added. So in this case, I start off as 5. The C out was done first, and then after that was complete, then I was incremented, and then the second time we did a C out, then it became 6. So that's the difference between having a plus plus in front and behind. Notice that we can also do this with minus minus. So the minus minus is the decrement operator. And we see that 5 minus 1 is 4, and in both cases I is now 4. And if I put the minus minus afterwards, what we see is that first I is 5. The C out is done first, then I is decremented to become 4, and then on the second C out we see that I finally gets decrement. So it's important to know how that works, because that will govern how these increment operators will be displayed sometimes. So the next thing we'll look at is accumulation operators. So with an accumulation operator, I might do something like this. I might create a sum equal to, in this case I'll set it equal to 7, and we might say, very similar to where we did I equals I plus 1, we'll do sum equals sum plus 10. And so we're basically using sum to accumulate values in it. We have initialized it, and then we're going to add something to what was already in it, and we'll display it. So we'd expect that sum would start off with 7, and then 10 plus 7 is equal to 17, and sure enough, we get what we expected. Well, again, this is a pretty common operation, and C++ has given us a shortcut to write that. And all we do is you put a plus in front of the equal sign. And what this means is add whatever's on the right side of the assignment operator to whatever is in the original variable and store it back into that variable. So if we do that again, what happens is sum will equal itself, which is 7 plus 10, and that gives us 17. We can also do this with a difference. Let's say that instead of sum we wanted to get a difference. We'll start it off diff as 7, and we'll say that it's equal, diff is equal to diff minus 10. And what we can see is diff is equal to 7, diff is 7 minus 10 is minus 3, that goes back into diff, and then it displays itself as minus 3. But again, we have a shortcut notation, and what this means is subtract 10 from what was originally there and store it back into itself, and we can see that we get minus 3, just as we'd expect. Now this can also be done with multiplication, and you can accumulate multiplicatively by saying it's itself times 10, and you multiply itself by 10, that's 70, and so it increased it by a factor of 10, and you can do the same thing with that kind of notation as well. So if you put the operator in front of the equal signs, this can also be done with division. You get the you basically get this operation done to the value on the left hand side and then put back in there. The next demonstration is using the modulus operation. So the modulus operation basically is to get the remainder after dividing two numbers. So I'll declare an integer mod to store the results, a numerator, and a denominator. The mod operation only works with integer values, and the way we use mod is we say numerator, and we use the percent sign to represent the modulus operation, and denominator. So this basically says take the numerator divided by the denominator and store the remainder in mod. I'll use a cout statement so that we can see the results. And let's try it. So we see that the mod of 23 and 5 is 3. How did it figure that out? Well, 5 goes into 23 4 times and has a remainder of 3, so the mod is that remainder. If I instead made it 20 and 5, we would expect that the mod would be 0 because 5 goes evenly into 20. And in fact, that's exactly what happens. We have a remainder of 0. And if I did 21 and 2, we would expect a remainder of 1. And in fact, we get a remainder of 1. So the next thing we'll do is learn how to use operator input. Sometimes when we're running a program, we want to be able to get input from the user. And the way we do this is off the IOStream library. We have the cn command. And the way to use the cn command is generally speaking, we send out a prompt first to the user. And then we use the cn command. We're going to need a variable to store our response in. And we'll get to the user response, and we'll just display it. Now you notice that these arrows are in opposite directions, and what that means is take the next item from the standard input and put it into this variable. So there's a buffer that the keyboard fills. Whenever the user types at any point in time, it fills this buffer in the operating system. And at any point in time, we can look at that buffer and pull off values that have been typed into it. And so as the program executes, first it prints out, please enter a number. And what it then does is it actually looks at the user input buffer, and when it fills up, it will pull that information in and fill this integer based on what the user input up, and it basically reads it up until the next carriage return. And so we'll see what this looks like. So I just hit Control F5. It's building and it says please enter a number. So I can hit 1, 2, 3, press enter, and we get 1, 2, 3. So that was a way for us to get the user input in. If I were to do it again, I could type in maybe another number, but watch what happens if I accidentally put some characters in there. It actually still read the number in, but it ignored everything that didn't make sense. So C++ tries to do the best it can with the user's input. If I put all characters in, it gets this really weird number, which basically that whatever that translated to in binary gets converted into a number, and so you can get some unexpected results with CN. So you will need to do some validation, which we'll learn how to do later. But what we could do is change this into a program which adds two numbers together. So we could say get two integers called num1 and num2 and add them together to make a sum. And we'll get num1, and we'll repeat this to get another number. I'm going to put a slash in here so that it appears on the second line. So we use our operators to do whatever function we want to do. In this case, we're going to do a simple addition. And so what we have is a simple calculator. We declare three variables, num1, num2, and sum. We get the first number from the user, the second number from the user using Cn, and then we just add them together. We forgot to change the second one to num2. Let's try this again. So for the first number I'll enter 5, 7, and I get the sum is 12. So we've made a simple calculator. We could also do this. Now watch what happens if I run this and I put in doubles or floating point numbers. If I put 5.6, and we can see that what happened is that it got the first number and it was able to take a integer off of it, and then the second number got this point, and so it did something weird. So sometimes if you get unexpected results from the user, you can get kind of weird responses with this. We'll learn better ways of doing this later, but this is a basic way, and as long as the user's doing what you expect them to do, this will work okay. So here I can put 5.6 and 7.4, and I would expect that to result in 7, 8, 9, 10, 11, 12, and 14, and 13. So that one worked. If I run it again and enter characters, I get weird results. But that's an example of how we can enter numbers and we can do some math. So this completes my operators demo for C++. Thank you very much.